Hello everyone, welcome back to this premium design course. Now let's continue to verify result with Tekla Tedds. Click on analyze, click on show result and select the folder analysis and click on result measurements and click on overlap. To show for, click on false. I will verify this column with Tekla Tedds. Click on this column, right click, open load analysis view. This is the actual for. Now let's open the Tekla Tedds. Click on new, click on steel design, where it is the steel, and steel column design, and double click on steel design 1993. Input the actual load 168.8, 168.8, and change to the moment measure is 483.9. I round it up to 484. 483.9. Keep it, and the shear measure assist is 80.6. 80.6. Okay, now we complete input the internal force. So now let's check for the column geometry. Lateral buckling length measure. We select from the strain factor. You can input direct. Now let me use the for option and change. You can input the length system and lateral length, buckling length on measure assist directly. I don't want to use the option. We use the restraint factor, and click on the buckling length, the system length lateral assist measure assist is 6,000 millimeter or 6 meter, and the restraint factor 1, and for the lateral buckling minor assist system length 6,000 millimeter, and unrestrained you can keep it 1. Okay, you see the result for the buckling in compression, buckling in bending, and combined buckling, and the lateral-torsional buckling length we input it 0.33 because we add the restraint at the location. Okay, at the location, connect from the girder to the compression plane or the columns. Now come back to the support document. Read monitor in the column in frame. After we run analysis, second first order analysis and check alpha critical, you can check in our model again and show tubular data and summarize square, steel, and column. This is the alpha critical in both direction 1 and direction 2. The alpha is greater than 10. So this structure is pre-frame or non-sway frame. The frame is sensitive to sway effect if alpha critical less than 10. Buckling length is equal to the column length. LCO is equal to 1 multiply with the L. L is the system length, and the LTO is the buckling length, and 1 is the buckling factor. Should be employed the second order effect. So if you run the first order analysis and get the result of alpha CO less than 10, you must continue to run the second order analysis one more time. Should allow for either by second order analysis or by amplified sphere methods. And this is the recommended factor, buckling factor 0.7, 0.85, 0.85, 1.0, depend on the restraint column in the frame. Okay, in the frame. And unfresh frame. For the unfresh frame, in the rigid joint unfresh frame, you can read more detail here. For the frame with alpha CO greater than 10, no need to make first second order analysis. Yeah, you run only first order analysis. And the maximum factor input 1, yeah, it's correct. It's the same with our concept with Tekla structural designer. Right now we call alpha critical greater than 10. In case alpha critical less than 10, second order effect need to be accounted. Column in single story building. Now in our structure 3D, we can include it as single story building. Yeah, it's a warehouse. You can read more detail. So the nominal pin at the back and fit. Yes, it's the same with our structure pin and fit at the top. The effective length factor usually use 1.5, and for the fit and pin 1.5, fit 1.2. But it's not must be used defector, because in plane stiffness of the frame provides the overall stability of the building in a measure axis direction, where overall stability is provided by in-plane rods and wall bracing. The effective length of the column may be reduced. Yeah, in the Tekla structural designer maybe use the effective length less than 1.5, but I don't know exactly the factor, because we can't check directly in Tekla structural designer about the factor, buckling factor. Okay, it's very hard. And as you know, in the plane stiffness of the frame provide the overall stability. It depends on also on the stability, overall stability of the building. So the value is less than the defined value in the recommendation 1.5, 1.5, or 1.2. So it's maybe 1.1 or 1.2 or 1. So the software will be automatically calculate and design the structure depend on its overall stability. It is very important and affect on the local member. So now let's come back to the Tekla Tedds and the buckling length. It is how we can keep it as 1 and 1. Actually, you can change it to 1.5 for the flexural measure axis. Buckling length, the factor is 1.5. Buckling factor is 1.5, and for the flexural minor axis, you can reduce it because we has intermediate restraint as girth or side rail, and we also add the torsional restraint at the bottom plane of the column, so you can reduce it in the case. Now let me reduce it to the minimum recommendation value. Okay, and you can click OK again and check the result is 0.88. In Tekla Textural Designer it's 0.813. Okay, come back. Now let me continue to use the factor. Yes, I do not want to correct it because the recommend value is only minimum 0.7. You can keep it. And for the lateral-torsional buckling factor, okay, we input 0.33, right? And click on finish. You can check the section utilization is 0.88 and compare with the Tekla Textural Designer is 0.81. I hope you enjoyed this tutorial. For more detail, can ask me directly in group. Thank you for your watching. Thank you.